What we're going to do in this video is we're going to design and implement a class for rational numbers. In order for this to make any sense, you have to have watched the previous video, which was an introduction to object-oriented programming. So what we want to basically accomplish is we want to write something. We want to make a new data type such that this program will actually run. So I want to create rational numbers, fractions. And I want to be able to say, for example, I have a fraction x, right? So I want to say like x is equal to the fraction 1/2. I want to say something like y is equal to the fraction 2/3. And I want to be able to say something like add x and y, those two fractions, and put into another fraction z. Now I can't do this directly in C++ because it doesn't support rational number arithmetic. So what you do in C++ is you create a new data type. That data type you do with a mechanism of classes, which we saw in the last video, and then you use the class to create these specific objects. And so this program will run. So when I say something like x is a rat and y is a rat, I declare this data type called a rat, and x and y are rats, that's going to be able to model things like this. So let me just go back and just explain a little bit of what we talked about the last time. So when we spoke about data types, we said that a data type is characterized by two things. Number one, it's the objects, the things that make up. It's a set, right? This is a set of things that make up that data type. So for example, for integers, we had 1, 2, 3, and so on, -5. And then what operations do integers respond to? So I can add them, I can subtract them, I can multiply them, and so on. Right? And so whenever I want to specify a new data type, those are the things I have to specify, right? So C++ provides me a template, a structure for doing exactly that. It gives me a way of describing what the objects look like and what operations do these new objects respond to. So if I'm going to create a rational number class, that's what I have to do. And we saw last time that essentially I do it like this. I basically say class, right? This is a reserved word in C++. I say class, and then I say the name of the class. So in this case, the name of the class is going to be rat. And then I open it up, and I close it. And this we called encapsulation, which means I'm putting these two things together. I'm putting together what do the objects look like, and then what do they respond to. And then there are going to be two parts to it, right? So this is going to be part one, right, describing what the objects look like, and then there is going to be part two, which is going to describe what these operations can do. That's the basic thing. I package these things together. That gives me the encapsulation, and then since this is the part over here that tells me what the objects look like internally. What's the computer going to do when I say, what's it going to make inside of the RAM when I say I have a rat? As we saw in the last video, I want to make sure that the users don't muck around in here. They don't play with the stuff in here. So I'm going to be able to describe this. I'm going to be able to tell my compiler that I don't want anybody to be in here. I'm going to be able to say this thing here is private. And in fact, we don't really have to say this, which we'll talk about later on, but it's nice to write that because automatically everything in a class is private unless I say that it's open for use. And to do that, I'm going to say public, right? I'm going to say public over here. It's all lowercase and with a colon afterwards. And what that means is that the users of my class, they can access this stuff, which is the operations on my rats, right? So if x is a rat and y is a rat, I want to be able to say add those two rats. If I want to subtract the rats, right, x minus y, I'm going to have, so all those things. How do you do addition? How do you do subtraction? How do you do multiplication of rational numbers? This I'm going to put in this section down here. And why do I declare them public? Because the whole idea is that they're public in the sense that the users of my class, the people that I want to use in their programs, my rational numbers, they have to be able to use the operations add and subtract and so on. So all that stuff goes in the public part, but the first part, in other words, what do they look like in the memory, that goes over here. So that's the basic outline. And now let's go back and see how this outline is actually done when you write the C++ program, when you write the class, when you define the class. So here is the rat class. First, we'll take a look at the whole thing, and then we'll go piece by piece. So it starts my declaration here that I have a class, and it's called rat. So that's right over here, and then starts the private part, which declares what the internals looks like. And so when I'm going to get a class, I'm going to create a new rat object. What do I need to do? What does a rational number look like? So if a rational number, say, is 1/2, this is called the numerator and this is called the denominator. So I'm going to have some way of representing the numerator and denominator. So I'm going to basically put two integers one next to the other. I'm going to call the first one n and the second one d. So whenever I say I'm going to have a rat, I need to be able to say this. So that's what it's going to look like. And so this piece over here, the private piece over here, and this is the part right over there that tells me what it looks like, right? So this is going to be 1, right? That's going to be the private. That's going to be the private part, right? I've declared private over here, and no one can get inside of it. The second part, right? The second part is from here all the way down. So notice we said that it's public, right? This part we said public over here. So what does public mean? It means that the users of my class can do that. And so these are the functions. These are the public, so I say public. And these are the functions that, right? These are the functions or the operations that the users of my class can do. So we'll see these. These are constructors, whatever those things are. And then some other functions and so on. And finally, the operations that I can do on my rational number. So here I'm defining the operation that lets me add them and so on. And I want to be able to do other things too. I want to subtract them and multiply them and divide them. And that I'm going to ask you to do once we understand how this thing works. So the class started out over here, right, with declaration of the class. And we saw what? We saw it started over there with an open brace that gives me the ability to package everything together. What's being packaged? This part is the part that is the private part that says what does it look like, and all the rest of this is the things of what can it do. And we call this is a what? This is encapsulation. So where's the bottom of the capsule? The bottom of the capsule is over here with the closing brace, and that's the end of the rational number. Okay, so we're going to now go through this thing in details, but that's the basic idea, right? I define it, I say class, the name of the class, I open it up, and I close it. And then there are two parts. First of all, I describe to the compiler what it looks like, and then I describe the section that says what can it do. And once I do this, it basically becomes like the compiler essentially puts this like into something like a glossary. And then when in my main program I say, look, I have a rational number x, and x is going to be initialized to 1/2, it'll create me one of these guys over here and put a 1 over here and a 2 over here, and then the functions will be able to use this representation. How? Well, we got to teach it, and that's what goes on in the functions over here. These functions have special names, and they are called member functions, right? They're member functions because they are members of the class. The data values over here are called data members. Okay? Those of you who've taken Java has a different name, but in C++, they call data members and member functions. Okay, let's see the details now. So the first thing that we saw is this part right over here, right? And this is the private part, and this is the part where we declare what the object is going to look like. And basically we tell the compiler, the C++ compiler, that whenever we create a rat, this is what the rat is going to have. It's going to be made up like this of two pieces, two integers, one next to the other. Automatically lays it out in RAM, one next to the other. And the first one's going to be called n for numerator, and the second is going to be called d for denominator. Now, what happens at this point? At this point, I can actually come over here and I can close the whole thing up, right? In other words, if I start it like this, right? If I start it like this and I end it right over here, that is fine. What that's equivalent to the following. So in other words, all I'm going to do, I'm going to get rid of this part, the part that says what can it do, and I'm just going to close the brace over here, and I have the declaration of the variables. That's equivalent to, if I say, let's say I have an integer I. Now, at this point, does I have an initial value? Is it initialized to 0? Absolutely not, right? All that happens is space is set aside. The compiler knows that when it gets to declaring this variable I, it's going to set up place in the RAM big enough to hold an integer, 32 bits, 64 bits, whatever your compiler does. What value does it initialize it with? It initializes it with nothing at all, right? So the equivalent of just being able, of just defining this part over here, in other words, where I say I have a class called rat, and then I say private, and I say what variables make up the object itself, right? In other words, the object is the thing that gets created by the class definition. You could think of the definition of the class as a cookie cutter, right? Imagine you have a sort of a cookie cutter like a circle, right? And you hold this thing like this and you make cookies. You have the dough laid out, and then you pick the cookie cutter up and you put it on the dough, and it just makes a whole bunch of cookies. Well, that's basically one way to think about what's going on over here. The class definition, when it says what it's going to look like, once I declare an object of the class, it goes into the RAM and it cuts out one of these cookies for me, the cookies being something that looks like that. Right? Hope that makes sense. So the difference between a class and an object is the class is the cookie cutter itself, and the object are the cookies that it makes. So when I say int I, it creates the space for an integer I without initializing it. Likewise, if I just have this part over here, I say class rat, and then I say private, and I put these definitions of int n and int d, and then I close the thing up, right? Just I put the whole thing without any functions and no initializations or anything. That's the equivalent of saying int I. So if I were to say rat x, right? So what this is declaring, just like here I is being declared as an integer, x be declared as a rat. Right? And all it needs is this definition to be able to do this. And just like when I say I is an integer, the compiler knows how big that's going to be. Likewise, when I say x is a rat, just like that declaration, it's going to create two ints, one next to the other, and it's going to know that one is called n and one is called d. Right? So, and what's the initialization? What's going to be in here and what's going to be in here? The answer is nothing. Just like in the integer, if I don't initialize it, it's going to be whatever random bit patterns you had. Whatever happened to be in the RAM before it's being used for I, likewise over here, right? X is not going to be initialized, and whatever random bit patterns were over there, they're going to be there, right? Now, what can I do with that at this point? Nothing, right? Not yet, because I don't have any functionality. With integers, once I have an integer, I can assign to an integer, and I can say I gets 5, and I can do arithmetic with I. Well, that's because it's built into the language, and the operations have been defined for integers. However, if I just, this part, right, if I just write this, right, just like that, then I'm essentially telling the compiler what it looks like, but I'm not telling the compiler what it can do. In order to do that, I have to put another piece over here, right, and I have to define, and I close it up like this, right, close the thing up. And so now I make the package of what it looks like and what can it do. And once I define that, then my class will be able to do things. I'll be able to, for example, if I teach the compiler how to add, I'll be able to say I have a rat x and a rat y, right, and a rat y, and then I'll be able to add x plus y, assuming I teach it. Now, why do I have to teach it? Because it has no idea where the rat is. Right, when the compiler came out of the, wherever they bought the compiler from, it had no idea that someone down the line is going to define an object called a rat. So if I want the rat to have the behaviors that I need, I have to teach it how to do it. Right. So this is step one. Right. Step one is to define what the object's going to look like, and that is that's that. Now, how do we tell it what it can do? Right. So that's the next part, and that's the part that first we say the next thing is public. Why do we say it's public? Because this is the interface. By interface, we mean how does the user interface with my class, right? Just like when you get into a car, how do you get the car to go? So there's an interface that they built. There's a pedal called an accelerator. It makes it go faster, right? There's a brake pedal. It makes it slow down. There's a steering wheel. It makes it turn, right? That's how you use the car, right? Internally, things happen, right? Things happen when you press on the accelerator. But you don't get under the hood and make the things happen by hand. You use the interface. You use the outside, and you do the appropriate actions on the car object. The car object is closed. The inside, as far as you're concerned, is private, right? But you just interact with it in terms of the public interface, right? The things they built for you to deal with it. Okay, so now we know how to create the object. Now let's try to make it do some things. So the member functions are this part over here, and basically it says, what can my rat do? So if we think about it, let's go back to the integers. I can say int I, right? We saw that. If I say int I, that basically creates an empty integer, and it's not, there's nothing in there. It hasn't been initialized at all. But I could also say, I can do the following. I'd say int I is equal to 15. And what that does, remember we spoke about this earlier in the semester, this is not an assignment statement, it's an initialization. So when I is born, it's initialized, it's given the value of 15. We didn't see yet the difference between initialization and assignment, but there's a fundamental difference, and we'll see that later on when we talk about what happens with these member functions. Especially, we'll define an assignment operator for our class, not for this class, but the next one we'll look at, and we'll definitely see what the distinction is. But anyway, I can initialize, right? So the question, so if I have a rat, I want to be able to initialize my rat as well. I'd like to say something like rat x somehow is initialized to, I don't know, 1/2, something like that, right? So I can do that, but the syntax is a little different. The syntax is like this. I say rat x and I say 1/2. And what that's going to do, remember when I say rat x, I'm going to get something in memory that looks like this, where this is the numerator and this is the denominator. And when I say rat x 1/2, it's going to put a 1 over here and a 2 over there, right? And you'll notice what does this parentheses remind you of? Reminds you of a function call, in fact, right? And what's going on is a function is called, and that function is called the kind of function that does initialization is called a constructor. So it might even be called initializers rather than constructors, but the term is a constructor because it constructs it. It gives it the values that you want, okay? So we're going to look at a number of constructors. You can have as many constructors as you want, and there's certain rules about making these constructors. So let's look at the one that we just used now. Notice we're passing in 2 arguments. This is a call on a constructor function, specifically a call on this one over here. And you don't make an explicit call. When the compiler sees this, when it sees it sees there's a new class here, so it looks in the class definitions, and it says, okay, he's calling a constructor, which constructor? And it does it by matching the parameters against by matching the arguments against the parameters. So here I have an integer and an integer. There are two arguments that I pass in. It looks around to the class definition. It says, do I have a constructor that has 2 integers? And the answer is yes, so it's going to use this one. So what are the rules about constructors? So the number of rules. First of all, a constructor, the name of a constructor is constrained. The constructor's name is the same name as that as a class, right? So if my class is called rat, and this was a capital, I can't say, for example, rat, because it's different, right? The capitalization makes a difference. So then I say I'm defining my constructor. Notice there is no return type. There's no return type. Just the name of just the name of the class, and then whatever arguments I'm going to be passing in. So I do it just like in a function in the function header definition. So here I say I have an integer I and an integer j, right? That's what I do over here, and then I put the body of the constructor, right? Because it really is a function call. But the point is, I don't do the function call. It happens automatically. So when I write this over here, right, when I say that, the compiler says he's calling a constructor. It's the constructor that takes 2 integers, and it does this. So what's going to happen when I say I have a rat, x, and I pass in 1/2? What it's going to do is it's going to say, where does this one go? This gets passed in for I, and this guy over here, that gets passed in for j, right? So I is going to get a 1, right? And j is going to get a 2. And so what's going to happen here is n is going to get the value of I. What is n? N is here in the RAM. It's going to now initialize these two variables in the actual object itself. So I goes into n, so that's a 1. J goes into the denominator, that gets a 2, and it's initialized. And what's the name of this object? Well, since I said I have a rat called x, and I call the constructor and I put in a 1/2 in there, so this guy over here is called x, right? So that's how I can do initializations, right? So that's the equivalent of when I'm dealing with integers. It's the equivalent of saying int I is initialized to 5, right? Int I is initialized to 5. So I'm declaring the variable and I'm giving it an initial value. That's what happens over here when I say I have a rat x and it's initialized to 1/2. It calls this constructor, the 2-parameter constructor, and it constructs. So at this point, if I do that, what do I need? What do I need for this to happen? So basically, I need to have the top part, right, the private part that defines what an object looks like, And then right over here, let's call this, let's call this constructor B, because we're going to have one right on top of it, right? This constructor B. So there's going to be a constructor B in here, and that constructor B is going to be called. Now, why is that public? Because I want my users to be able to have access to it. It's true that it's implicit. They don't call the constructor. You can't call the constructor in C++, except in one very, very rare case. But we're not going to talk about that here. But other than that, it's implicitly, the compiler implicitly puts it in place, and it's going to work. Okay, that makes sense? Very good. Now, I can do something else also. In other words, I can say, what happens if I now say I have a rat y? Just like that. So now, there is no, I'm not calling in initializations to happen. But let's say I want, right, and that's what we saw earlier, that if all I put is the part 1, this part over here, and I close the brace down here, I can declare variables, but they won't be initialized. Let's say that I want them to be initialized. So for example, what do my rats represent? What do they represent? Basically, they represent fractions. So what I want to make sure, let's say we spoke about pointers, right? We said whenever you declare a pointer, you better make sure you initialize it, say to 0. Otherwise, if it has some arbitrary value, you can really get into trouble when you dereference it. It's going to send you someplace in memory. You can do real damage. Make sure you initialize your pointers. So imagine I have a similar situation with rational numbers, right? I want to make sure I initialize it, because what happens if by accident, the compiler gives me some space, right? Let's say here's my rational number. By accident, the part that J gets to occupy has a 0 here. And if I forget to initialize this, or I didn't initialize it, somehow it's going to give me a divide by 0. That's not good. So what I'd like to do is I'd like to be able to define a constructor, but I'm not going to pass any values in there. I'm not going to do like I did over here with the 2-parameter constructor. But if I do that, I want it automatically to give me a default initialization, right? So if I don't pass it in, I want a default initialization. Now, I'm the boss here, right? It's my class. I can decide what I want to do. So I might as well make I want to make sure the numerator is going to be, not 0, right? But I might as well initialize, if you think about, if I could have, an automatic initializer for my integer, it makes sense to initialize to 0, right? Many things are initialized like that. So how about my fraction? I also initialize it to 0. So I might say something like the numerator is 0 and the denominator is 1. So if I say, why not, right? We can do it like that. So if I say this, if I just say, I have a rat called y, and I don't provide any initializers over here, so I'm going to get my default constructor to be called, right? My default constructor to be called. That's the constructor that gets called by default unless I tell it otherwise. And notice the default constructor, how do I recognize it? I recognize it by there's nothing in there, right? Inside the parentheses. It still needs the parentheses because it is a function call, essentially. It's called rat, right? There's no return type. It's definitely a constructor. And what I'm going to do is I'm going to give default values, and I'm going to give the default value of 0 and 1. Okay? So that's a default constructor. Now you might want to know, why could I not, by default, over here, give default values, right? In other words, right over here, when why couldn't they construct a language in such a way that when I say integer n and integer d, why could I not do something like this? Why not say, let me give default values, say this is equal to 0 and this thing is equal to 1. Why not let me do that? And the answer is, in fact, you can now do this, right? From C++ 11 on, you can actually do the initialization when you declare the variables, the data members in the class itself. You can do this initialization in the actual declaration, but initially you could not. But if you're using the compiler of C++ version 11 and on, that is now legal. But you can do it either way now. You can declare the default constructor, or you can do this. Now, there's some difference, and we'll see what the difference is later on. I just wanted to make sure that you understood that that was possible now. Okay, so now we see two constructors so far. The default constructor, and we're going to call that one A. Here, that one is called A, and the other one's B. So we're going to have A, and we're going to have B. And what are we doing here? We're creating the member functions. Okay? All right. So now, now we're going to see, how about something like this, right? Let's say I say I want to declare a rat like this. Does this make any sense whatsoever? I'm declaring a rat, and the rat's name is X, and I want it to be a 5. Well, how could that possibly be? I mean, I'm looking at fractions, and 5 is not a fraction. But of course, 5 is a fraction. It's really 5 over 1, right? So if I wanted 5 over 1, I could have said x, 5, and 1, right? 5 being the numerator and 1 being denominator. But I'm going to want to do stuff like this because I want to be able to use integers like later on. I want to say x plus 5. And so I want this to be able to be converted into a rat, so I can add one rat to another rat. We'll talk about that in a little while. But I want something that if I just use integers, and since integers make sense as a rational number, right? 5 is really 5 over 1. I want a constructor. This is my constructor C. And it's going to convert, that's why it's called a conversion constructor. It's going to convert integers into rats, right? And like that, right? So it's very simple. It's very simple. And this is what it looks like, right? So if I say rat, we just saw here, if I say rat X and I say 5, so what's going to happen? What's my parameter here? There's only one parameter, that's the I. So 5 goes into I, right? So I can construct one of these things over here, my numerator and denominator. So I goes into the numerator. I is 5. I get 5 over here. The denominator is preset to be equal to 1. So this gets converted to 5 and a 1, right? So that's a conversion constructor. So we have 3 constructors now, right? We have the default constructor, which is A, which gives me a 0 over 1. It's essentially giving me a 0 fraction. The second one, which takes 2 parameters, lets me initialize anything that I want, any kind of rational number. And the third one was a conversion constructor. So this is C. That constructor lets me convert an integer to a rational number. I just wanted to repeat again what public means and so on. So public means, that's this pot over here. Public, we're saying that everything is public, means that the user, when the user uses those functions, he's not going to get a compiler error, right? And what are the constructors for? Just to be clear, they are initializers, right? Right? Constructors are initializers. So at this point, before we move on, I just want to clarify one thing. We said that the variables, that the data members over here, these are all private, right? No one's supposed to be able to access them. However, look at the member functions. The member functions are actually accessing them, right? When I have this 2-parameter constructor. So I'm taking these, I'm taking the parameters, and I'm going to initialize. So my member functions are certainly accessing, right? When I have the conversion constructor, it's certainly accessing the internals, right? So what does it mean to say that they're private? Well, so private means that users of my class have no access, right? But the member functions definitely have access, right? That's why when we make the capsule, by encapsulating everything, those member functions, those functions that are part of the encapsulation, they certainly have access to the internals. Analogy might be something like, if you think about the government, right? That might be a useful analogy. So the government is also sort of looks like this, right? You have some internal state. Let's say the president, right? Right. So nobody has access to the president unless, I guess, you give enough money to the appropriate political party. But otherwise, no one has access. And the president sort of personifies the government, right? But how do things get done? Assuming they get done, what happens is around the president, So there are a bunch of he has cabinet secretaries, right? Because the whole thing is the government, right? The government is both circles together. This is the internals that represents basically what we've been calling the private part. No one can deal with the president, but let's say I have a Department of Agriculture, right? There's a whole Department of Agriculture. I have a Department of Defense. Have a Department of Interior, have a Department of Education, right? And each one of these has a secretary. Now, if I want to access the government, I can't talk to the president. I say if I want to go to the agricultural department, have a farm, and I want to get something done, so I go here, right? And I make my queries over here, and then they're going to, I mean, conceptually, this is not what happens exactly, but they will be able to access the president. So the Secretary of Agriculture, he has access to the president. I don't. I might have access to the Secretary of Agriculture via his department, by the Department of Agriculture. Likewise, if I want to get some grant, some educational grant, so I am over here, I talk to the Department of Education, and the guys at the Department of Education, they can talk to the president, right? So this over here, right, the insides, this is the private part, right? That's the private part. And these guys over here, these are the public part. So as a user of the government, I access this. I have no access. I can't get in here, right? I can only access the government agencies, right? The government agencies through the secretary has access to the internals. That's why all my member functions can access. This is somewhat of a simplification, but that's basically the idea. They can access the internals, right? Even though they're declared to be private, they're private for the users of the class, right? They're private for this guy over here, right? But they are not private for these people. These guys can actually get in, right? They can talk to the president. So what can I do till now, right? I can basically say I can declare a variable. I can say I have a rat, and his name is X, and I can initialize my rat and say 1/2. But let's say, if I would do the same thing with integers, if I say I have an integer I and I initialize it to 0, then later on I can go and I can say, you know, I want my I now to be 15. How do I do the same thing with my rat? Okay, this is the initialization. That's the equivalent of saying I is equal to 0. But how do I change it, right? So remember what a rat looks like, right? A rat, this 1/2 looks like this, right? There's a 1 over here and a 2 over here. There's the numerator and denominator. So what normally is done is to create member functions, and the informal name is accessor functions. Accessor functions it's not a C++ term, but it's a term that's used within the community. And the accessors allow me to read the value of a data variable, one of the member data, and then to write them, right? So I have accessors that let me get, right? The ones that just read are called getters, and these guys are called setters. Now, how do they have access to change? Again, because they are member functions. So let's see how that would work. So let's say I declare my rat X to be 1/2, and now I want to make it, let's say, 1/3. So I want to get in here and change the 1. I want to make it into, change the 2. I want to make the 2 into a 3. So I'm going to define a function called set, right? And I have two sets. I have a set enumerator and a set denominator. So if I want to set the value of the denominator, I call set denominator. Now here there's a special syntax that we've seen before. Let me just show you how that will work. So, and then I'll remind you where we saw it. So I have X, right? And X, remember, has now 1/2, right? X now looks like this, right? Here's X, and there's a numerator and a denominator and a 1 and a 2. So what I want to do is I want to change the 2. I want to change the 2 into a 3, right? That's what I want to do here. So I do it by saying take X, right? Take X. And on X, I want you to call a function called set denominator. So I say X, and then I put a dot over here, right? And then I put the name of the function, and this function is called set denominator. It doesn't have to be uppercase, lowercase. That's just the way I decided to do this, to highlight the fact that it's the denominator. And then I put an argument in here, and if I want to change it to a 3, I would say x dot set denominator. Now, where did we see this before? Remember when we looked at vectors, right, for the non-recursive towers of Hadoi problem. So remember, a vector, we didn't have the terminology yet, but if I say vector int, and v is the name of my vector, so, right, we said something like vector, right, I have a vector int, and I call my vector v. So this vector int is an example. This thing is a class, right? Forget about, it's a class, right? And v is an object. So when I wanted to, let's say, to go let's say to read the back element, what did I do? I said v dot, remember the dot, back, right? I call the back function, and I use that. So generally, that's what happens when we have objects, and I want to call function on the object. I put the name of the object over here. I put the function with whatever parameters I'm passing in over here, and then I use the dot to say, call this on that. Okay? So that's the way this works. So when I say x dot set denominator to 3, it's going to go in here, it's going to call this function, right? And what does this function say? It says take the argument. What's the argument you're passing in here? Take the 3 and put it where? Assign it to the denominator. So it's going to set the 2, and it's going to make it into a 3. So I'm going to get, instead of 1/2, I'm going to get 1/3. Couldn't be simpler, right? And likewise, if I want to set the denominator, right? If I now want to say set the numerator, I'd say take x, set numerator to 5, right? So what's going to happen over here is the name of the object. That's this object over here. It's going to call set numerator. Set numerator is going to get, it's going to take the argument I pass in and put it into the numerator, right? So it's going to take the 5 is going to go into the numerator, and the 1 is going to become a 5, right? So at this point, what can we do? We can, number 1, declare. Number 2, we can initialize. And number 3, we can actually change the values by using these setters, right? Now let's say I want, right, that makes sense? Now let's say I just wanted to print out my x, right? Let's say x is still 1/2, and I wanted to print out x. So without anything further, later on we'll see we can actually teach it to actually, say, I want to be able to say, eventually, I want to be able to say, C out, and if x is a rat, I want to say C out x, right? And it'll know how to print rats. But right now it doesn't know how to print rats. Why? Why doesn't it know how to print rats? Because we didn't teach it to. But I can even do it now. I can print this rat even before I teach it how to print rats as a unit, very simply, right? I can say C out, left shift. What do I want to print? The numerator / denominator. So I say take x, and then, right, then get, so dot, get n, right, get the numerator. Notice there is no, it's an empty parentheses, just like back was on the vector, get numerator. Now, what does get numerator do? What does get numerator do? Let's check it out. Get numerator basically returns the numerator as an integer. It doesn't do anything. This was changing stuff, right? When I said set it, it took the I and it changed the numerator, or it changed the denominator. This is just returning the numerator, right? So if I say C out x dot get numerator, what's going to happen is it's going to print, in this case, a 1, right? And so let's say, and then what? And then what? And then let's say I say, and then say print, a dash. And then, so now it's going to print what? It's going to print a 1 followed by a slash. And then I say take x again, right? It's going to go to my x, and I'm going to say get the denominator, right? X dot get denominator. And what's going to happen now? What's the denominator? The denominator is a 2, so it's going to print a 2, right? So I get it to print out, even though I can't print, right? It's different than saying, C out, the whole x, and it knows how to print rats. It doesn't know how to print rats yet, but since I can get inside the rat with my getters, I can then, I can sort of not fake it, but I can get it to print the rational number. Okay, hope that makes sense, right? If not, stop the video, go back. But so now I can do, again, let me just summarize. I can declare an object, right? It can stamp out that cookie. I can initialize it by using the constructors, and I can read what's in there with my getters, with the get numerator, get denominator, and I can change the values with my setters. Now we have to look at the arithmetic operators, because I want to be able to say something like x plus y when x and y are rats.